we're going to use this function to model exponential growth and decay. It's very similar to what you've probably seen as your continuous compounding interest, the PERT. Very similar to that. What we have here, the A on the left is going to be the accumulated amount or accumulated value. The A with the sub-zero, we call it A naught, is the initial amount. Okay, you could think of 0 being at 0 time. E is that number, the 2.718. K is going to be your rate. And the growth rate will be a constant. And then T is going to be the time, so the time after you start observing. And you know that if you have a graph of an exponential, it is going to look like this. Okay, it shoots up, and your initial point right here, that's going to be your initial value. And we need to find where is our accumulated value at a certain time. And very similar to the growth model is the decay model. But there's one difference, and I'm going to put it right here. It's going to be negative, okay? Your K is going to be negative. And what happens to your graph, it takes all of your T values, which were over here on the right, and it's going to flip them over. They're going to reflect, and now they're all going to be on the left. Okay, and then all of these values will be this way. And so you see what's going to happen to this graph. It's going to look like this. I'll put it in green. Okay, and you can see the decay. You can see that you had values up high, and now they're getting lower and lower and closer to 0. And we are going to model the decay. For example, the decay of carbon-14. You have carbon-14 in a living organism, and over time it all starts to leave. And so you can find out how old something is by using this model. And in the examples that we are going to see, they're going to give you some of these things. They're going to give you the initial amount, they will give you the rate, and then they might give you the accumulated value, or they might give you the time. Now, if they give you the time, then it's just going to be a calculated problem. Okay, you'll have this number, you'll have this number, you'll have this number, put it in your calculator, and you will find the accumulated value. But if they give you the accumulated value and not the time, you're going to have this, you're going to have this, and you're going to have this. Then we have to solve for t. And you will have to use the natural log here to bring that t back down to earth. Okay, let's go ahead and look at some problems.